Why was the universe born with a reservoir? You can think of it as a reservoir of order, which can unravel over billions of years and allow complex structures to exist.
In January 2025, something happened that may have brought us closer to an answer. Google's Quantum AI Lab, in partnership with astrophysicists from Caltech, fed raw deep field data from the James Webb Space Telescope into one of the world's most powerful quantum processors. What they found shook the foundations of physics: light patterns that defied known models, energy signatures that shouldn't exist, and perhaps, most astonishing of all, evidence that another universe may be leaking into ours. Is this a software glitch? A quantum illusion? Or have we just glimpsed the edge of a parallel cosmos? Stick around, because by the end of this video, you'll see the data, the mind-bending theories, and the implications that could change how we understand reality itself. Chapter 1. Quantum AI meets deep space. Classical supercomputers are incredible. They can simulate galaxies, gravitational fields, and dark matter filaments. But they have one major flaw: they can't fully model quantum interactions. They reduce probabilities into clean averages, smoothing out the weirdness that might actually hold the key to new physics. Quantum computers, on the other hand, process information using qubits, units that exist in superpositions. They can hold multiple states at once, making them ideal for simulating quantum phenomena, including the quantum structure of cosmic light. So, when Google's team asked, what would happen if we analyzed unfiltered James Webb data using quantum AI? They weren't just looking for clearer images, they were hunting for what lies beneath the visible universe. They started with raw photon counts, spectral data, and gravitational lensing maps, the kind of raw telemetry that classical models throw out or simplify. Within hours, the quantum processor surfaced patterns that didn't belong. Infrared bands were distorted in ways no known process could explain. Even stranger, photons from distant galaxies were entangled in non-local correlations. In simpler terms, light from opposite ends of the universe was mysteriously linked. These weren't one-off anomalies. Repeated tests with fresh random seeds all produced the same results: arcs of light appearing and vanishing in sync, as though another universe was bleeding into our own. Then came the biggest shock of all. Chapter 2. Geometries from beyond. The anomalies weren't just distortions, they were structured. The data formed arcs, repeating across multiple deep field observations. These weren't statistical glitches, they weren't noise. They were signals, structured, geometric, and eerily persistent. When mapped across different fields of view, these arcs intersected with known dark matter filaments, as if hidden mass was pulling on our photons from somewhere else. It was then that one theory resurfaced: brain cosmology. According to string theory and its M-theory extension, our universe might be just one brain floating in a higher dimensional bulk. Other brains, parallel universes, could lie just millimeters away in extra dimensions, invisible to us, yet exerting subtle effects. And what if, under specific gravitational or quantum conditions, information could leak between brains? The AI's findings hinted at just that: quantum leakage, an invisible influence from a parallel universe shaping the photons we receive. Suddenly, the James Webb Telescope wasn't just peering into deep space. It may have been peeking through the cracks in our reality. Chapter 3. The gravitational mirror. As if that wasn't enough, another anomaly emerged. The team noticed an unexpected mirror symmetry and gravitational lensing. Clusters of galaxies on one side of the sky were bent by gravity as expected, but on the other side, they were bent in the opposite direction, as if there was a gravitational mirror at the center of the field. This symmetry was observed in 3 separate sky patches. It was as if a parallel brain, rich in mass and gravity, was pulling light from our universe and reflecting it back. A researcher described the experience like standing between 2 mirrors, but the other reflection is a universe we can't touch. A cosmic feedback loop, a hall of mirrors connecting realities. Chapter 4. The participatory universe. To understand why this is so profound, we need to revisit the ideas of physicist John Wheeler. Wheeler proposed the concept of the participatory universe, the idea that observation itself plays a role in creating reality. In quantum mechanics, particles don't exist in a definite state until they're measured. Wheeler extended this to the cosmos. What if the universe only fully materializes when it's observed? Now, imagine a quantum computer making billions of measurements per second. Not observing from a distance, but entangling with the raw probability fields of deep space photons. When Google's processor analyzed Webb's unfiltered data, it wasn't just performing calculations. It was collapsing wave functions that had never been measured before. And what emerged from that collapse was strange. Chapter 5. Many worlds, one glimpse. This theory suggests that every quantum event splits the universe into multiple realities. One where the photon goes left, another where it goes right. Reality endlessly branching. Normally, these parallel timelines are sealed off from each other. But what if Google's quantum AI briefly bridged them? With enough entangled qubits and deep space data, the quantum system may have become an interdimensional observer, momentarily aligning probabilities across multiple branches, not just seeing light from our cosmos, but glimpses of others, realities just out of phase with our own. The data didn't just look off, it looked like a reflection, a skewed twin of our universe seen through the lens of entangled photons. One physicist put it simply, we're not just looking at the universe anymore. The universe might be looking back, through all its versions. Chapter 6. A message in the light. Just when things couldn't get weirder, they did. Late one night, a sub-team decided to examine the spectral noise, data typically thrown out as background error. But instead of filtering it, they ran it through a prime number decomposition model, a method usually used in cryptography. And what they found was impossible. Across multiple datasets from different sky regions, the fluctuations in the noise aligned with the first 101 prime numbers. Not once, not in one patch, but repeatedly. Statistically, this was like flipping a coin 1,000 times and getting heads every time. Was this just an unknown astrophysical phenomenon? Some bizarre interaction of lensing and quantum interference? Or was it intentional? Primes are the universal language of mathematics. They're not tied to biology, chemistry, or human culture. If an intelligent entity wanted to communicate across dimensions, primes would be the way. And this wasn't a message. It was something more intimate, a handshake. Chapter 7. A cosmic handshake. When cross-checked with ESA's Euclid mission, which used different instruments to observe different regions of space, the pattern still held. No calibration error, no solar interference. One researcher leaned back and said quietly, "This feels like a handshake, a mutual recognition, a meeting point between realities." And in that moment, everything changed. This wasn't first contact with aliens. This was first contact with the architecture of the multiverse. The universe is speaking back. So what does all this mean? Maybe it's all coincidence, a cascade of anomalies, interpreted through wishful thinking. Or maybe we've just opened a window into something vast, recursive, and alive. A universe that isn't sealed, but leaks. That doesn't just exist, but responds. A universe that might be whispering to us in the only language it knows, light. And maybe we, armed with quantum AI and our endless curiosity, have just whispered back. Subscribe now and ring the bell, because this is just the beginning, and the cosmos has so much more to say.